Hi everyone. So today we're going to work on rational exponents. So in other words, we're going to be able to write our radicals, our cube roots, our square roots, our fourth roots, with instead of writing it with the radical symbol, we're going to write it as a fractional exponent, which means we're going to be able to do like all those laws of exponents that we did way back in the day. So today we're just going to practice writing from exponent to radical, radical to exponent, and then we're going to do some simplifying and incorporate that negative exponent because we want to talk about him separately. All right, so by today we're going to write as a rational exponent and then write rational exponents as radicals. And then we're going to simplify some expressions involving rational exponents. All right, so when we talk about rational exponents, that basically means that we're going to have, let's call it a, to some power that's a fraction, like n over m. That's usually how I write it. Okay? Or a to the 1 over n. Let's make this m over n. Okay? So we're going to be able to write radicals with the fractional exponents. Okay? That's kind of like the goal. We're going to have a fraction in an exponent that's a fraction. And it's going to mean something. Is a fraction. Okay? All right. So a to the 1 over n is equal to the nth root of a. So 1 over n means nth root of a. A is non-negative, and n can be any natural number greater than 1. When a is negative, n can be any odd natural number greater than 1. So in other words, our root is the denominator of the fractional exponent. Okay? All right. So let's take a look at this. We want to write an equivalent expression using rational notation and, if possible, simplify. All right, so here we have 16 to the 1/2. So the denominator is 2. So that means square root of 16, which we know is 4. That's it. That's all we're doing. Okay. All right. So here we have the denominator is 5. So we have the 5th root of a, b, c, whole thing underneath the 5th root symbol. That's all we're doing. Okay, so try 2 and 4. Okay, so we have negative 8 to the 1/3, so that's the cube root of negative 8, which is negative 2. And 25x to the 16th is square root of 25, x to the 16th. So the square root of 25 is 5. The square root of x to the 16th is x to the 8th. And we don't need to do anything like put absolute values around that because x to the 8th is always positive. All right. So let's go the other way. So I'm giving you the radical. You have to write it as an exponent. The 5th root of 7ab. So we have 7ab. We're always going to use parentheses when it's more than one number or variable. And my root is 5, so 1 over 5. Let's try this one. Okay, so 5x, we're going to use parentheses. Our root is 2, right? Square root, so 1/2. All right, try 2 and 4. Whole thing being taken to the 1/7. Okay, so I just use parentheses. We're not doing anything else. All we're doing is moving it from a radical to an exponent. 4th root of 2ac, make sure we're using parentheses, because otherwise the only thing being taken to the 1/4 power would be c, and that's not right. It's the whole thing, so we want to put parentheses. Okay, so, all right, so take a look and make sure we're good. The root is the denominator of the fraction. Okay. Now, if your radical also has an exponent involved, that kind of changes it a little bit. All right. So for any natural numbers m and n is not equal to 1. Wouldn't make any sense. The nth root of a, that means that a to the m over n is the nth root of a to the m, or the nth root of a to the m. So basically this means that the root, or your index, is the denominator. And the exponent is the numerator of the fractional exponent. Okay, so let's try this one. Okay, so notice our we're going from fractional exponent, rational exponent to radical. Denominator is 3. So that means we're going to do the cube root of 17. And you can put the squared right there. So the exponent can go there. Okay. Move this over. Or you can write it as the cube root of 17 squared. Your choice, both mean exactly the same thing. Personally, you're going to see me write it the second way, because especially with evaluating, that's the easier way for me. Okay. All right, try number 2. Now here we have the square root of 25 cubed. So I took the square root of 25, which is 5, and then I cubed it, which is 125. Okay. Now we're going to go the other way. So my root is 3, so I have 9. Denominator of our fraction is going to be 3 to the 4, and then numerator's 4. That's it. Okay, so over here, try this one. 7xy to the 5/4. Okay, so if there's an exponent involved with your radical, it becomes the numerator of your fraction, and the denominator is still your root. Index is another word for it. Okay, all right. So let's incorporate one more thing and then we'll be done. Negative exponents. So let's remember. Okay, do we remember this? It's equal to 1 over x to the n. Somebody once told me the phrase, the base is in the wrong place. So that means we're going to move the base from being in and make it a fraction. So, okay, so don't get confused between making it a fraction and a fractional exponent. You're just going to move it from where it is and put one over it, okay? Or flip it upside down. Okay, so let's try a couple of these. So we're going to do all of these together. Now be careful, okay? All right, so here it says the rational number m over n, okay? A to the m, negative mn means 1 over a to the m over n. So it's just 1 over. We're going to make it 1 over the number that we get. Keep in mind that negative exponent does not mean make it a negative number. People do that all the time, and we don't want to do that. Okay? All right, so let's see if we can do this. So negative means 1 over. The 2 means square root. And 1 means an exponent of 1. So 1 over the square root of 9 is 1/3. Okay, take it step by step. Do the negative, so 1 over the 5th root. And I'm going to use 5xy, whole thing to the 4th power. That's as far as you can go. Let's make sure that we don't need to go any further than that. I do not believe so. We're good. Okay? All right, let's do this one. 1 over the cube root of 64 squared. Okay. Cube root of 64 is 4. So 1 over 4 squared is equal to 1 over 16. So if you can take the cube root or the 4th root or whatever, do it. Okay, let's try this one. Oh, doesn't look good. Okay, now here's the thing. The only thing being taken to the negative power is the x. If I wanted other things, I would have used parentheses. So the 4 is going to stay. We can make this 1 over x to the 2/3. I'm not quite ready to change that yet. And the y to the 1/5 stays. So I'm not going to change this one. I think I'm going to leave it all with fractional exponents. So 4y 1/5 over x to the 2/3. We'll just leave it just like that. Okay. All right. So be careful. That was a trick question. All right, let's try this one. Ugh. What are we going to do here? Negative, and it's a fraction. Well, that just means 3r goes to the bottom and 7s goes in the top. It just flips it. So we're going to flip it over. Notice I didn't flip the fractional exponent. I just flipped what was being taken to the negative exponent. So 7s over 3r. We're going to leave it just like that. Not going to do anything else. Okay, let's try this one. Okay, so let's see who's being taken to the negative power. 16 and the w. Okay, so p to the 2/3 doesn't move. 16 to the 1/2, w to the 3/5. Now, that again doesn't mean take the fraction and make it negative or flip it over. It means move it to the bottom. Now, we can do 16 to 1/2 because remember that just means the square root of 16, which is 4. If we can do numbers, we're going to do numbers, but variables we're going to leave just like the way they are. Okay. All right. Take a minute. See if you have any questions, okay? Process that. Think about it. All right, guys. Let me know if you have any questions. Please stay safe out there, and I'll talk to you again real soon.